Science experiments together, shall we? Let's make sure I got everything here. We're going to do some science experiments with some glow sticks. Oh, welcome aboard, everybody. It's Tommy Technetium coming to you live. Going to do some science experiments today with some glow sticks. So welcome aboard. You're here. Let's see. It's kind of fun to notice this. Let's see. I've got how many different glow sticks here? 1, 2, 3, 4, 5. Let's look at this one here, all right? I'm going to go ahead and get this one glowing. Let me pop the lights off here. Here we go. I'm going to snap. Oh, look at that. Isn't that interesting? That red color. Boy, it looks white. To my eyes, it's looking pink. Let me see if I can't fix it just a bit on the camera. Yeah, it's a little tough. So to my eye, this is looking kind of pinkish. You can see the color kind of that I'm seeing. It's just so bright, it's saturating out the camera. But this is the color of the glow stick that I'm seeing here. I'm going to put this one back just for a bit. All right. It's kind of cool. We'll turn the light on, and you can see sort of what it looks like here. I'm going to go ahead and get this one glowing here. You'll see the dye in this one's kind of like got a peach color. Let's see what happens when I get this one glowing. Oh, that one's already spent. How about this one? Yeah, this one's ready. So this one, you can see it's kind of like colorless, maybe a faint yellow. Boy, that one I already got going too. Maybe, okay, we'll do this one. Sorry about that. This one here has got like a green color. I can tell it hasn't been snapped. Like a yellow-green. And, of course, when I get that one glowing, it's got a green color. Let's try this one here. This one looks yellow. Oh, that's also... All right. How about this one? This one looks colorless. Yeah. But when I get it glowing, it's got a blue color. Now, how is that happening? You know, it looks... The dye that's in there is colorless. And yet it looks blue when I get it glowing. Hello there, fishmen. So it's kind of interesting. Just like, you know, different markers have different colors. They have different colored dyes. Different glow sticks have different colored dyes. And I'm going to show you this. I'm actually going to try to change the color of this blue glow stick by changing the dye that's present. Okay? We'll give it a shot, see what happens. We'll move these two off. And let me get a little bit of paper towel down here. All right. And then we're going to cut this baby open, see what happens. I'm going to have to get another glove on. All right. So we're going to cut that blue glow stick open, pour out the contents, and we're going to try to change its color by changing... Hello there, Ryan. Sorry, I'm not saying your name right. Hello there, Joseph. We're going to try to change the color of this glow stick by changing the dye that's present. Because just like different markers have different colored dyes, different glow sticks have different colored dyes. So here's the beaker we're going to use. All right. And let me go ahead and get my PVC cutter. This is how I cut them open. Thanks. We'll put this in the back. This is where I'm going to store the material. Oh, no, Joseph, this is a great experiment. I got my goggles on. We're all set. I'm going to really carefully open this. You see, I just gently cut across the top. Okay. And then this is going to go into my waste container, and we're going to dump this out. And then this can also go in the waste container. It's more fun to see this in the dark. So let's do another one here. Isn't that beautiful? That's just beautiful. It is. So we're going to look at this glow stick, which you can see in the light, it looks colorless. But when I, of course, crack it and get it going, it chemiluminesces a blue color. We'll cut this open, get some of the material that's in there. Hello there, Addie, excuse me. So really carefully, I'm going to cut open the top so I can get to the contents of the glow stick. Okay. We'll pour it in here. And one thing we can show, before I try to change the color, here's another interesting experiment that I'm going to show you. One thing I can show you is they use a catalyst to, you know, control the degree of glowing that's occurring. So I'm just going to pour a little bit out over here that we'll use later. We'll pour it in here. Hello there, Kevin. Hello there, Leo. In it goes. So we've got two separate glowing fluids, yeah. And to this one over here, I'm going to add some base. And the base that I'm going to add is sodium carbonate. Sodium carbonate is a base, and bases do catalyze these reactions, which means they speed it up. I don't have a scorpion here with me. Hello there, Sylvia. Can I add some baking soda, yeast, and hydrogen peroxide? Sorry, Alina, I don't have any of that stuff present. But here's the super washing soda. This is sodium carbonate. I'm going to add this to this flask over here. That both of these have the same glowing blue fluid in it. Let's see what happens when I add a base to this one over here. Here we go. We'll pour a little bit in, and you guys can tell me what you see. In it goes. Can you tell? Can you tell? Look at that. Compare the glowing of the two. Maybe you can see that this one is glowing much more brightly after I added the sodium carbonate. That's because the reaction is kicking off and it's going more quickly. It goes more quickly in the presence of base. Oh, sorry, Leo. I don't have any. Oh, cool there, Addie. Glad to hear it. Now what I'm going to try to do is I'm going to try to change the color of this glow stick by adding a different dye. And the dye I'm going to add, let's see if I got it here. Yeah, we'll just add some red food dye, okay? Just add some red food dye and see if we get a different colored fluorescence. Chemiluminescence is actually what we're looking at. So here we go. You get this in here. We're going to add a drop of the red food dye. Swirl it in. Thanks there, Leo. Appreciate that. Swirl that around. Come on, baby. Look at that. See that different color change? You can tell we've got some beautiful red fluorescence going on now. A little bit of like red-orange, maybe. And, of course, that's combined with the blue fluorescence that's originally from the blue light stick. You know, we have a mixture of two different dyes. And by changing the composition of the dyes that are present in the glow stick, we, change the color of the glow, the chemiluminescence that's occurring. I want to see if I can get white. They say all the colors of white, red, green, and blue, right? RGB. They say that makes white light. Well, let's see if we can do that. So you can make this look more white by, let's try it this way. Green's kind of intense. We're going to try to get a white light stick by mixing red, green, and blue. So give me a second here. I got to find my PVC cutter. All right, we got blue in here. We're going to take a little bit of the green glow stick. I'm going to add just a bit. Get that baby cut open. Give me a second here. Oh, come on, baby. There we go. I try not to cut real sharply because that makes things spread all over the place. Here we go. We're going to add some green to the blue. Hopefully that's not too much. You can see that there's now kind of like an aqua color to the glow. It looks a little more white. Let me just give it just a sniff of red and see if we can't make this look more white. We're getting close. So RG and B, red glow, blue glow, and green glow should give us a more white glow. Swirl it around. I don't know about you, but that looks a little more white than before to me. Just a bit. It's still got a greenish tint to it. I think I got a little too much green in there, but it looks like I've got a bit of a white glow stick by mixing a red glow stick, a dye that fluoresces red, a green light stick, and a blue light stick. Pretty cool. I agree. Some of you may think that it's looking a little bit red to me now. Since that's looking red, I think I'm going to try to let's just add a bit more green and see what happens. And if that doesn't work, I'll add a bit more blue. Let's see here. No, that's really looking red, man. That looks way red. Yeah, Rhiannon, I agree. It's not looking right. Let's just dump it all in. What the heck? Just pour it all in there. Why not? See what's happening. Oh, I'm loving glow sticks. I call them light sticks sometimes, so forgive me if I slip and do that. You can see I got a little bit on my hand here, right there. I'm going to wipe that off on my paper towel. Denny, we are doing experiments with glow sticks. You can see I kind of made, that kind of looks orange. So by mixing the green glow stick mixture and a little bit of red food dye, it looks like I've made an orange glow stick. It gets a little intense. The light gets a little intense, so you can't quite see. Come on, Skylar. Holy mackerel. The chemist has entered the chat, recognizing we've got an oxalate ester, definitely. Definitely. Rain, you're asking what would happen. I apologize. I don't know what the question is in reference to. Hello there, Bubble Line. What's going on? I'm gonna try here. Let's just add a little bit of red to the mixture, shall we? I guess it's more violet than red, or pink than red. Let's pop some of this in there. No, I won't be drinking of this anytime soon. So yeah, the different colors of light sticks, glow sticks, they come from different dyes that are contained in the glow sticks. And, you know, you just change the colors by changing the relative proportions of each dye. So I'm now adding some pink. Look at that. Look at that. It's like an eyeball in there. So, yeah, I'm just changing the proportions of the dyes that are present in the glow stick. And when you do that, you change the color. Very simple. So I'm going to go ahead and give this a swirl. Boy, it's like I'm seeing like two different colors chemiluminescing at once. So it's like I'm seeing... Can you all see that? It's like a green and red all at the same time. Do different dyes react differently with some things like contaminants? Sure, all chemicals are going to act differently on some things. Skylar noting, oxalate can form stones in the kidneys. Indeed, definitely can. If this were to be ingested, Rain, I had a dog that ate a glow stick once. I've done experiments with these a lot. And she sure didn't like the taste of it, but, you know, it didn't kill her. No, this won't explode. What happens if, thank you there, Matt, what would happen if you drank an oxalate ester? You know, the manufacturers of glow sticks claim that they are non-toxic. And I have observed this in my dog, as I was mentioning earlier. I had a dog that ate a glow stick. It was the funniest thing. I was in the dark, you know, working on the computer. My dog comes around. I could hear her like going, like she was making noises with her mouth. I could tell that she didn't like something. Her mouth was glowing because she chewed the glow stick. And, you know, it didn't kill her or anything. But, you know, it's like Paracelsus said way back in the 1500s. Everything is poisonous and nothing is poisonous. It's the dose that makes the poison. So, you know, I'm sure if you ate enough of these, it would not go well for you. Cockaver, thanks for saying hi. Matt, what a funny question. No, I did not know that. I did not notice that, Matt or Loke. Can you chemically change its color? Denny, you can. You totally can. What I will do is I will try to do so simply by adding some red food dye. That's right. Red food dye does indeed fluoresce. And so if I add some red food dye to this, it should shift the fluorescence to a more reddish color. Let's see. Hello there, Larry. I'm going to add a couple drops here. It takes a bit for the red food dye to mix in. So you can see right now in the middle, that droplet in the middle where the red food dye is, it's not chemiluminescing. And that's because it's separate. It's like some water, and the glowing fluid is like an organic mixture, and the two don't mix. But if I agitate it enough, I should be able to get the red to dissolve into the glow stick fluid. Indeed, I see it. I don't know if you all see it, but that looks a lot more orange than it did before. And if you don't see it, I'll just try to add a bit more. Hello there, AJ. Let's add a little bit more here. Another drop. Once again, you can see that water droplet in there with the dye in it, it doesn't dissolve into the organic layer until I agitate it. And after you agitate it, it will indeed mix in. And yeah, that's looking a lot more orange-red to me. And the reason why it's changing color is because the dyes in here, they're all special dyes that we call fluorescent dyes. Fluorescent dyes can give off energy as light if they gain energy. And the chemiluminescent reaction in a glow stick, there's a powerful chemical reaction that's powering the glow stick, and that reaction gives energy to the dyes, which the dyes then give off as light. I agree there, Loke. It's kind of an interesting, look, we got a bunch of different colors going on. Am I explaining aggregation-induced flu, Vanita? I don't even know what aggregation-induced flu is, so no, I'm not describing that. Hello there, Kane. All right, let's try this again. Let's use, oh, this one's got the base in it, so I'm gonna pour this material into my flask back here. And so this contains some base. This beaker contains some base, and base catalyzes the reaction. So I'm going to go ahead and pour this mixture into here, and the reaction should speed up. So let me go ahead and just pour that in there into the base. Oh, look at that. Come on, man. Come on, man. Look at it. It looks like lava. So you can just see the reaction just took off when I poured it into the base because it's indeed a based catalyzed reaction. Look at that. Come on, man. It's like fire. So the reaction takes off like crazy, which of course means that it's going to glow more brightly, but it's also going to go out quite quickly. So if you watch, we're going to keep stirring this. It's going to go out much more quickly than it otherwise would have. So the glitch says they and their sister had a whole bunch of glow sticks and decided to make a lava lamp, which is just what it looked like I made. So they cut open the glow sticks and put it in a small jar with water to make it glow, and they made their hands glow too. Oh, yeah, I agree, Denny. It was like lava. That was cool, Luke. Thanks. I agree, Penguin. Skylar. Hello there, Mario. All right, let's get some more glow sticks open here. We're going to put that in the back. That should, that should relax over time. But, man, that was a really nice glow that we got going. Really nice effect. And I'm surprised that it's actually still glowing. Hello there, Liam. I'm surprised it's still glowing because a lot of times when I add the base, yeah, it takes off, but also the reaction goes out more quickly. All right, let's try some other colors here. I got this one's going to be blue. I'm not going to find out, Luke. And yeah, let's do a bunch of blues, all right? We'll do a couple blues here. This is what I find interesting. What's interesting is there is a dye in here. So this is a glow stick. The glow sticks have dyes. It's just that this particular dye, to our eyeballs, it has no color. So, the way it interacts with light is such that, when it's not glowing, it has no color. And yet, when we mix the dye that's present in this glow stick with the glow stick reaction, it glows a blue color. I find that fascinating. That, under some circumstances, when it's not emitting light, the dye is colorless, and yet when it is emitting light, it looks blue. I find that to be kind of remarkable. Okay, let's get this in our flask, do some experiments with it. I'm going to go ahead and cut this off. Thank you there, Penguin. It does seem like magic, but you know what? The way you can look at it, the whole doggone thing is magic. The whole entire universe is magic. But it's all also just science, too. All right, here we go. Let's get another one in there. What would happen if I gracked it? I'm sorry, Elijah. I don't know what that means. Thank you there, Lumity. There's another one. Now we have lava and water. I love it, the glitch. How does it work? Well, we can go into that. It's going to, we're going to have to stop doing some experiments for me to explain that, and it won't take that long. I can pull out a quick sheet and show you how it works if you wish. Yes, Denny, if you keep it cold, it does make it glow for longer. It makes it glow less brightly. It slows down the reaction, and when the reaction slows down, it lasts longer. It's like a slow-burning fuel, which lasts longer, or a quick-burning fuel, which will last longer. I'm liking what I've got I've got so many different dyes in my flask here. It kind of looks like a rainbow in there, a rainbow of colors, until I swirl it around. Now, I saw a shift to green. That shift to green is probably because there's some residual dye in there. Actually, it's looking white on the camera. But that shift in color from blue to green is because there's other dyes that are present in here that I wasn't able to clean out. Yes, it's glass in there. So they keep, in the glow stick, they keep the different components separate because you don't want this glowing all the time. You don't want the reaction going until you're ready. And so they keep the different chemicals separate. So inside here, there's a glass ampule that when you do that, it breaks the glass. And then the two components mix, and that's, allows you to get the get the glowing. Rainbow vomit. What if you burn it? It would indeed burn. You know, the chemicals in here are carbon containing, and so they would indeed, combust. But I've never tried that. Not going to happen, John Doe. That's not the kind of chemist I am. I'm not a synthetic chemist. If you drink it, you'd probably get, you wouldn't like the taste of it. I can guarantee that. Agreed, Denny. They must engineer the plastic so that it can handle the glass. Okay. Looks like we got kind of an aqua glow going on. Yeah, because we got a lot of blue and green together. So it looks like Popcorn says these things taste nasty. They may have tasted them. No, you definitely wouldn't want the glass inside you for sure. All right, well, I'll show you how we can change the color of this glow stick mixture. Yeah, I agree there, Penguin. Thanks for noting that. The red one has kind of petered out. So this one, remember, I added some the base catalyst to this, and so it glowed really brightly at first, and then because the reaction was going so fast, of course, it peters out. I mean, we can try it again here. We'll try it again here. All right. Not going to happen, Bison, with your pea glow. Come on, man. Okay. We're going to take this guy right here. Remember, this has some base in it. It's sodium carbonate. And I'm going to take this glow stick mixture, and we're going to pour it into this beaker here, which contains the base. And the base is going to catalyze the reaction. What is the catalyst made of, Denny? It is simply sodium carbonate, which I get from this super washing soda. A variety of bases will catalyze this mixture. All right, here we go. What other stuff do I have other than glow sticks? I got some like color changing rainbow stuff, which is kind of cool. Lumity, I have not watched that. Here we go. I'm going to pour the glowing green aqua mixture, and we're going to pour it into the base, and we're going to see what happens. Here we go. Come on, man. Come on, man. Look at that. It's like, oh, I love the lava. The lava action is just glowing so much more brightly when it gets, added to the base. Look at that. Isn't that just gorgeous? It's like just a bunch of different fluid. I'm going to give it a swirl, and let's really get this going. There we go. As it mixes in with the base catalyst, of course, it speeds up. But then it dies down. You can see it's not as bright as this over here now. So this gives you, a quick flash where the reaction goes really fast, but then it peters out. All right, let's do a little forbidden lava lamp. Here we go. Let's do a little more. I'm not going to do that, Adzi. All right, here we go. Add a little more. In it goes. Yeah, probably I do it, Kane. Thank you there, Helen. Send me a line. Let me know how it goes. Look at that. Come on. Look at that. Oh, that's gorgeous. It's like I made lava. It's not, of course, but it's cool. Oh, that was beautiful. So it's going really fast. I'm going to swirl it around. The reaction's happening very fast, but because it goes so fast, it's also going to die out quite quickly, and we can see that happening before our eyes. We get a beautiful red glow. Looks like tomato soup with a swirl of cream. Glowing tomato. I'll take the glowing tomato, waiter. Bottoms up. No. Yes, Game King, it actually is exothermic. Now, most of the energy is released by light, but I've done some careful experiments where you can measure the temperature of the fluid as the chemiluminescent reaction is going on. And indeed, it releases energy, so the temperature goes up. In my basement, Lumity. No, this is not what's in lava lamps. This is not what's in lava lamps. All right. Let me get a fresh glow stick here. All right, I'm going to pop this back in here. And, oh, no, I don't want to do that because this is contaminated with the base. So we're going to put that back here. I want to keep this here. All right. So it looks like I got this color glow stick, which we've seen before, chemiluminescence blue. I am doing it in my house, Lumity. I've got this glow stick here. And What else do I? That's pretty much it. I think I got these two. Well, this one looks a little darker. These different glow sticks. So you can see a dark red, a light red, and a blue. All right. Let's just try them all. Let's see what happens, okay? Here we go. We're going to get this one glowing here. That's the one that's blue. All right, we'll put that one back there. Let's try this one here. Yeah, I'm a chemist, Skylar. I'm a chemistry professor. Oh, look at the beautiful red color that one is. That's just really beautiful red. On the camera, it's kind of looking orange, but that, to my eye, that's a really gorgeous red color, like a deep red. Not quite a cherry red. All right, let's try this one here. See what this is. Yeah, I would think that you could mix it with some. I think that one was already. No, that one was already broken. Let me try another one. Sorry about that. Try this one here. This is kind of the same color as the other one was. So here we go. We need to mix glow sticks. What happens if you freeze it? Um, then the glow lasts longer, but it's not as bright. Yeah, that's probably true there, Skylar. All right, let's mix these two together and see what we get. You want to? Let's mix the blue glow stick and the red glow stick in our flask and see what happens. That's an interesting question, Crown. I don't know. I don't know what would happen if I tried to boil this, but I love the question, man. What would happen if you drink it? Probably nothing. It probably just wouldn't taste very good. I know this because I was telling people I have a dog that ate one of these. All right, there's our blue one. In goes the blue glow stick mixture. That's an interesting question too there, Popcorn. Chill. We're not going to worry about that, all right? The dog's name was Jezebel. Jezebel, she was a great dog. She died back in 2013. Hello there, Stefan's Verse. Welcome aboard again. There we go. Let's add this red glow stick mixture. And here, let's get this out. Hello there, Fish and Black. Crownbot, you know what? What do you think it's going to be, Crownbot? Crownbot says it's going to be purple. Here we go. Do these chemicals ever mix in nature? Probably not. Do I have any yellow ones? I don't. Have I ever seen the glow grills? No, I haven't. I do an experiment with High Voltage Planet. I electrocute a pickle in one of my videos. If you want to go through my shorts, you can find the electric pickle video. It's kind of fun. Is it toxic? Arturo, the manufacturers, that does look kind of like a pink. The manufacturers of the glow sticks claim it is not. However, if we remember Paracelsus's admonition back in the 1500s, he remarked that everything is poisonous and nothing is poisonous. It's the dose that makes the poison. So I'm sure if you drank enough of this, it wouldn't be good for you. But I imagine if you drank this flask, you might not like the taste. Can we add oil and see how it mixes? Come on, Loke, let's do it. Come on, Loke. Loke says, can we add oil? Why not? Let's do it. Let's do it. Here we go. Well, Nocturnal. Water's toxic if you drink enough of it. So the question is, how much do you need to drink for it to be bad? Again, I had a dog eat one of these, so I know she consumed some. But she lived a long, healthy life for a Labrador. She lived to 13 years of age, and I think she did it when she was like 8 or something like that. All right, here we go. Thanks there, Nocturnal. I'm sorry. I don't mean to be condescending. I just, Anyway, what is a glow sticks made out of? Hey, let's talk about that. I don't have any liquid nitrogen, Mr. Chris Matthew. Here we go. We're going to add some oil. Loke was the one who, here's the oil. There's my, I don't know what's going to happen. I've never done this. Let's see. Give it a shot. Here goes. Had Mentos. Come on, man. I like the liquid nitrogen idea, too. Here we go. In goes the oil. You can see the dollop of oil right there in the middle. I imagine it's going to mix because I think the fluid is nonpolar and oil is nonpolar. So these two should just mix. Oh, look at that. It put it out. It put it out. So it looks like the oil quenches the fluorescence. I mean, I can still see here a little bit of glowing, but that's from, I know it's hard for you to see, but that's from yeah, let's see if we can, there you can kind of see it. It's from the glass ampule on the inside of the glow stick, and the oil is unable to penetrate in there, and that's why that's still glowing. But for some reason that I don't know, it looks like the oil quenched the fluorescence. Yeah, I've heard of now, Red. I agree, Crownbot. That was pretty cool. Please explain quenches. So when we talk about fluorescent dyes, those are dyes that emit light under certain conditions. And these dyes are all indeed fluorescent, which is, you know, under the certain conditions where they're exposed to the chemical reaction that I'm messing around with, they indeed will give off light. We use the term quench fluorescence, you know, fluorescence is quenched, when that means when you add something to a fluorescent mixture, it stops the fluorescence. And there's different, you know, mechanisms by which that happens. But in that case, you know, we empirically can say, because we all observed it, that when I added the oil to the glow stick mixture, the fluorescence went down. A quicker way to say that is the fluorescence was quenched. What happened if it lit it on fire? That I don't know, man. Do nukes explode because protons compress? Oh boy, it depends on the type of nuke, right? I mean, in my opinion, I thought nukes exploded, well, based on a wide variety of things, right? You can just get a critical mass of fissionable material, and that's gonna go, baby, go. Okay, Tin G wants us to add baking soda. I don't have any baking soda. However, Tin G, I do have some sodium carbonate, and we're going to do that next for Tin G, okay? Thanks there, Loke. We might get to those, okay? So this is for Tin G. We're going to go ahead and mix the glow stick mixture with some sodium carbonate, which is a base. And sodium carbonate catalyzes this reaction. So let's get a glow stick going. We're going to do a blue one, all right? And unfortunately, all of my flasks have been contaminated here. Wait, I can do this. I don't want to contaminate it. Let's get a fresh little, just going to get a fresh little bowl here. What's the highest voltage potential I can get using only household chemicals? Christopher, what a great question. What a great question. I did it with copper pennies, Play-Doh. That's right, copper pennies, Play-Doh, and zinc washers. I mean, it's nothing to write home about, but I was able to get a potential of 5 volts using those, just making some electrochemical cells with the copper and the zinc and the Play-Doh, and, you know, arranging the cells in series. I do have a pet, Popcorn. My pet's name is Ruby. So can I explain catalyzing? Jonathan, I can. So in a chemical reaction, we have things called reactants that get transitioned to products. So let me show you this. We're going to talk about catalysis here. Let me show you this particular reaction. We'll just stick it right back here. We'll look at this. So this is the glow stick reaction that you can see there in the back. Hold on. I'm just going to do this just for a second. Forgive me. So we can see this a little bit better. Okay. So this is the glow stick reaction, or at least how we represent it. So it's actually in the, if I remember correctly, so in this glow stick, there's a glass ampule on the inside that when you crunch this, it snaps and it breaks. So there's a material on the glass ampule on the inside, and that's usually this thing over here, hydrogen peroxide, okay? That's usually on the glass ampule on the inside. On the outside of the glass ampule, there is this molecule that we call TCPO. It looks kind of complicated, right? It looks like it's got 2 big eyeballs on the side, all right, and a bunch of gunk in the middle. And also in the TCPO, we have some dye, and we have a base, all right? So Inside the ampule, peroxide, outside dye, base, and TCPO. When you snap this, those chemicals mix and off goes the reaction. Well, what's the reaction? Well, the reaction is this TCPO molecule. I want you to focus right here in the middle. You see how it's got a C here and a double bond O? Here, let's get a little closer. It's got a C double bond O. It's actually got two of those, and then it's singly bonded to an oxygen. Well, man, that looks pretty close to carbon dioxide to me, CO2, right? It's like you got a CO2 right here, and you got a CO2 right here. And what happens is the hydrogen peroxide snips the molecule right here and right here. And so you get two of these shortened eyeballs, so to speak, and you get this thing that, boy, that looks like it wants to be carbon dioxide. Like there's like a CO2 on this side and a CO2 on this side, but they're connected. We call this a CO2 dimer, or sometimes we call it dioxetane dione. This is the special ingredient, though. This is why we do this reaction. We really want this thing here. Because what happens is this CO2 dimer reacts with the dye that's present, and it goes to carbon dioxide. Two of them, of course, because you can see them right there. There's the two CO2s. But what happens is the dye gets energy, and the only way that we know how to kind of convey this is we put dye star. This means this dye's got some energy, man, and wants to get rid of it. All right? And that dye gives off the energy as light. So there it is, man. That's what's going on. And the reason why we add base, the question was, how does it catalyze the reaction? The reason why we add base is because it catalyzes the reaction. That means it speeds it up. So anytime you add a catalyst, it's slightly more complicated than that, but basically it's just something that's going to speed up the reaction, okay? So here we go. I'm going to go ahead and add the catalyst to this beaker. Right there. Whoop. Spilled a little. So there's my base. I added it in. All right. So this has got a bunch of base in it. It's got a bunch of the catalyst. I'm going to just get one more of these open. Chemically excited states. Come on, Christopher. You got it. We got some chemists in the chat, man. I'm loving it. Good to hear, Austin. Okay, let's add a little bit over here. So this is our control over here. And now we're going to add a little bit of this glowing mixture to this flask, which contains some of the catalyst base. Here we go. And it goes. And look at how much more brightly that's glowing. Now, you'll also see the color has shifted. The reason why the color has shifted is because there's some other dyes in here. This just has the blue emitting dye. This had some residual other colors of dyes, which is why we got the color shift. So you're seeing a lot of different things in action. Now, the other thing you'll notice is that this is kind of petering out because a catalyst does speed up a reaction, but it also makes the reaction go out more quickly. It's just like, you know, if you burn a log, if you burn it quickly, it goes out more quickly. That's all. The fire goes out more quickly. So a catalyst is going to not only speed up the reaction, it's going to make it go out more quickly. Here, let's add a little bit more here. Denny, I can rinse the flasks, but not with water. So I'm going to have to rinse these with acetone later. Boy, look at that. We're just firing up, baby. Look at how brightly that's glowing. So you can definitely tell there's a catalyst in here from that huge, look at that, just really enormous glow. And then it's going to settle down. Add lime? I don't have any lime. Oh, you mean calcium hydroxide. You guys want me to add some acetone, huh? So Bester, in the United States, we use the term alkaline and basic. So an alkali and base are synonymous. So I am indeed adding alkali to, you know, when I added it to this beaker contained alkali. Thanks there, Mitsu. Well, I don't know. I don't know if I got much left for you here. I guess I got a few more light sticks. You guys want to keep going. But I will tell you, at the end of the live, I flipped the camera around and I'll let you guys see my ugly mug. Just let you know. An opal of chem lights. I love it, Austin. I flipped the camera around. I talked to you all. If that's something that you don't want to see, then, you know, here's your warning. In about 5 minutes, you're going to see my ugly mug. You're going to see an old man in his basement. There's your warning, folks. It's coming in about 5 minutes. So that's not something you want to see. Just know it's coming, all right? And thanks there, CDN. CDN said, "Ooh, I saw something shiny." Love it. Okay, let's go ahead and cut this guy open. There we go. All right. We'll dump it in this. Yeah. All right. And now we're going to dump it in the base. Can I add water to the blue one? Sure, we can add a little bit of water. If I remember correctly, water quenches the fluorescence, but let's find out. See if I remember correctly. So I got here, I'll show you what I'm doing. Somebody want me to add water. Here we go. We're going to add some life water. What happens if an object of radioactivity touches an object of higher radioactivity? As far as I know, in almost all cases, here we go, I'm going to add in some water. You know, it's very difficult to affect the rate of radioactivity of anything. So then goes the water. I don't know, did I get brighter or not? It kind of looks the same to me. I'm going to swirl it around. Like radioactivity, that's brighter, man. Come on, man, that got brighter. What the heck is in, you know what? Come on, that's cool. I think this stuff might be a base. Let's see, it's got potassium bicarbonate added. So sure enough. So here, I'll show you this. That's really cool, man. That is really cool. So I know this stuff is basic because I read the ingredients. It says it's got potassium bicarbonate in it. You're like, come on, man, what are you talking about? Well, let me show you here. So I'm going to go ahead and I'm going to get some of this sample of water here. I mean, hey, I saw it glow more brightly, and the only thing I can think of that made it glow more brightly is a base. So that means this water must have some base in it, and I'm going to test that right now. Hey there, the glitch. Hello there, Harrison. Here we go. We're going to go ahead and add in a little bit of water, and if this is basic, it should turn my universal pH indicator like a blue or a violet color. Let me show you what I mean here. Here's my universal indicator. That's a great experiment. So I forgot who suggested it, but I'm going to do that again because that's a lot of fun. Hello there, UTSAV. And then, Denny, we should try distilled. So here's my universal indicator. So if we see this stuff turn blue or violet when I add it to this, then my hypothesis is correct. If not, then my hypothesis is incorrect. What I love about science is, this isn't going to be a failed experiment. I never have a failed experiment. All I do is observe. All I have is new observations, baby. That's all I do. Try to see what is, man. All right. Hello there, Emad. So if I drink both, you'll glow even brighter than just... Here we go. All right, let's see. My guess is it's going to turn blue. If not, I've got some explaining to do. Here we go. Uh-oh, look at that. It's green. It's green. Interesting. I don't know, folks. I'm stumped. I would definitely have expected that to be a blue color. I know there's potassium bicarbonate in here. I mean, it says it right there. So it does contain a base. And I do know that the universal indicator, well, I don't know. I really don't know. That's a surprise to me. Do I know how to make glowing orange liquid? Yeah, man, I can make you some glowing orange liquid. Thank you there, CrownBot. Great suggestion. I wonder, yeah, that's kind of cool. I wonder if different waters will make it glow differently depending on the contents of the water. That's a fun experiment, man. Let's do it. Come on, let's do it. Okay, so I got some Fiji water. I got some Fiji. I don't know if this is going to work or not. I got some Avion water. I got some Life water. What else do I have? Let me pour this in here just for now. We're going to try this. You guys got me doing extra experiments. I'm going extra time here because of it. That's okay. What other waters do I have? I got some Aquafina. Let me go get some Aquafina. And then we'll test. Oh, I got some Essentia as well. So I got Essentia and I got Aquafina. Cool. So we're going to test all of these waters to see, to see which ones make the glow stick fluid glow more brightly. And maybe it's just the water itself. I don't know. Maybe all these waters will do it. Have I ever read that? No, I did not, Bester. I think I was Morrison and Boyd. Was the was my organic chemistry text in college. So, Bester, did you ever read the Crabtree and Minge's book? All right, here we go. Let me just pour this in here. We got some tests to do. So how many different types of water I got? 1, 2, 3, 4, 5. We're going to get this out of the way here. So I've got to get enough fluid to test 5 different types of water and see if some or all of them induce greater fluorescence. So let's get our control going here. All right. I'm down to 3 more light sticks, so this is going to be it. All right, light stick number 1. You read it for fun. That's awesome. Okay, let's get this guy open. I don't have any tap water on hand. Sorry there, Crown. Sorry about that. Maybe next time. All right, that goes in. Let's do light stick number 2. What else glows? But lots of stuff glows there, Glitch. So yeah, I mean, like these dyes would glow without, you know, you could just shine ultraviolet light on there and they're going to glow under ultraviolet light. So, you know, there's a lot of stuff that glows under ultraviolet light. So a lot of fluorescent dyes will glow. This is having a little trouble here. Let me try to get that near the top. No, I don't have any beer either, Loke. Sorry. Okay. That's funny there, CDN. Come on, man. This stuff is stuck. Hey, somebody do me a favor. Tell me what the score of the Detroit Tigers game is. Man, they've lost like 12 of the last 13 games. I couldn't watch today. I'm getting so upset watching them. So I came down here and decided to do a live. So please tell me, what's the score of the Toronto Blue Jays and the Detroit Tigers game? If anyone can figure that out for me, I'm going to be so upset if they're behind. Here we go. There we go. All right, let's get this one going. Nobody's let me know the score. I don't have any sodium, Tingy. Not with me here. Sorry. All right, get that one in. There we go. Come on, they're still up 3-0. Thanks, Crown. That's what they were when I was what inning are we in? We getting near the end of the game? Come on, baby. CDN. I'm loving it. Tingy, I don't have any sodium. Sorry. I don't have any sodium on hand. But if you want to see sodium in water, you can certainly go to my YouTube shorts. I have several experiments in there where I add sodium to water. Okay, here we go. Top of the 8th. Thank you. Appreciate it. Thanks there, Grift. Appreciate it. Okay. Tingy, I've already answered you. Please stop spamming the comments or you're gone. Okay, here we go. Let's put user in timeout. Let's go 5 minutes. Okay. Here we go. All right. Let's do Aquafina first. All right. So this is our control. I'm going to mix our control. Allie, we're just looking at glowing blue glow stick fluid. And right over here, I've got a little bit of Aquafina water. And I'm going to add, come on, Jose. I'm going to add a little bit of the glow fluid to Aquafina water. We're going to see what happens. And it goes. And that's what I would expect in Aquafina water. The glow kind of is quenched relative to the Aquafina, to the glow stick, because Aquafina has a low pH. It's like pH 6. So it's a little bit acidic. It's just a little bit acidic, and I'm not surprised at all to see that when I poured the glow stick fluid into Aquafina water, that the glow went down because it's base that catalyzes the reaction. And so if you pour it into acid, the base will get neutralized. It'll slow down the reaction, and that's indeed what we saw with the Aquafina. All right, let's do the next one. So next on the docket is going to be Avion water. So here's our Avion water. Avion water does have some basic additives, so it might be the case. I don't know. We're going to find out. It might be the case that this will glow a little better. So here we go. We're going to watch. I'm going to pour some Evian water into this cup. Denny says 2 little glow fluid. We're going to do about the same amount on each test, Denny. Okay. Here we go. Let's pour it in and see what happens. And it goes. That one looks a little brighter. Yeah? This one looks a little brighter than the Aquafina water. It didn't seem to go out. It's not glowing quite as brightly, but nevertheless, it did not go out. And I'm thinking, we can add a little more just to be sure. I don't know. Just a bit more. Yeah, it's a little bit glowing. Yeah, the more acid, the more it will go out. The more the base, the better it will glow. So that one was our... That one was our... shoot, I forgot. What was that one? That wasn't our Evian. Okay, now I'm going to try Essentia. Essentia is like pH 9.5. So this one's got a lot of base in it. So it's a high pH. So I imagine this one's gonna look kind of nice, is my guess, because base catalyzes the reaction. So there's our Essentia water. All right, let's pour a little bit of the glow stick fluid in there and see what happens. I don't know. Look at that. That's not bad. I think that's glowing a little bit better. You can kind of see the beads of the glow stick fluid in there. It doesn't mix with the water real well. But yeah, that's not glowing too badly. Right here, we can compare these two. Oh, shoot, that almost spilled over. So this is from the Essential water, and this is from the Evian water. You can tell. So CrownBot asks, isn't water supposed to be pH 7? Yes, if it's absolutely pure. The issue is that at first, any water that's exposed to the atmosphere will have carbon dioxide dissolve in it. And if carbon dioxide dissolves in water, it lowers the pH. The second thing is that they add additives to the water. And if you have additives in the water, that's going to change the pH as well. Man, that Life water really seemed to glow. So I want to just test that one again. I don't understand what the heck's going on with the Life water. I got to be honest with you. There's something cool going on in there. Like it really glowed. Maybe that was just a fluke. So I'm going to try the Life water again. Bester, probably nothing unless you had an ignition source. So there's our Life water. There we go. So we're trying the Life water. And in goes our... Here we go. It's okay. It's not the best. It's not bad. It's not great. But yeah, it's glowing pretty well. I'd say... I mean, it looks like it's glowing better than the others. Here, let's take this out so you can see it a little better. Yeah, it does. I don't understand it. The interesting thing is that the glow stick from the glow doesn't really mix with... Yeah, so Glitch, it is what we call a non-polar fluid. And non-polar fluids don't mix well with water. Yeah, I like cats. Here we go. Let's change the color of the glow stick. This is the last thing I'm going to do before I flip the camera around. Talk to y'all. If that's something that you like. We're going to go ahead and... I agree there, Funny Egg. I agree. I'm going to go ahead and try to change the color of this glow stick mixture just by adding a drop of red food dye. Let's see what happens. What happens if I had copernicium? I wouldn't add it because I'd get rich if I had a bunch of copernicium, wouldn't I? That's a pretty rare element. Boy, that's just not mixing in, huh? Or it's just a... Yeah, let's see if we can get that in there. Come on, baby. Get in there. It doesn't seem to be working real well. I'll add just a little bit of base. Maybe that'll do the trick, all right? Just add a bit of base, and then we're going to call it good. Let's do this in the dark so we can see if it actually makes a difference. Oh, yeah. Come on, baby. I love that. Come on, man. Look at that. That's so cool. Look at that red fluorescence. It's like it just took off when I added the catalyst base. It's so beautiful. So really cool. All right, guys, let me flip this around. Talk to you for a bit, and then I gotta go watch the end of the Tigers game. Hello there, Cindy. Here we go. How's everybody doing? How's everybody doing? Here, let's make this look pretty, huh? Come on, man. Get this going on. I got to get the lighting right. You know, when you're old like me, you got to have good lighting. There, that's a little better. A little dark, but that's okay. Hey, what's going on, Melee? NF, we just did a bunch of experiments with glow sticks. Had a good time. Had a real good time. Thank you there, Glitch. Appreciate it. Yeah, just talk to folks for a second, and we'll, you know, I'm going to call it good. Hi, Cindy. In my opinion, which water should be the one you would choose? Allie, any water is pretty much fine. Some people like Fiji. You know, different waters do taste differently. I do admit that. Like people tend not to like pure water. So if you drink Aquafina, Aquafina has been purified and they don't add anything back. And if you pay real close attention, you'll notice its taste. It's got like a bite to it. And that's because it's slightly acidic. And what they usually do is they add small amounts of basic salts back. And what that does, you know, bases, they impart a soapy or slipperiness to water. And so that gives a smoother feel on the tongue. Aquafina has that sharp taste because it doesn't have any base added. It's kind of cool. If you really pay attention, you'll know what I'm talking about. So water with basic additives, basic salts, it'll feel kind of smooth. My favorite element, Crown, is hydrogen. How about y'all? Glitch, I haven't tried coconut water. I need to. Melee, we're talking a little bit about chemistry. Bester if I added it to bromine. I think we might see some fireworks if I added it to bromine. I've not done that. I do too, Cindy. I do too. Heavy water, that'd be interesting. Do I have a favorite chemical? Carbon dioxide, Dane. I absolutely love carbon dioxide. Carbon dioxide and water. Like, it's hard to choose between those two. But yeah, everybody else in the chat, feel free to drop in your favorite element. I'd love to hear about your favorite element or maybe your favorite chemical. I mean, I like think of the top, you know, that's the 7 chemical wonders. One of them is hydrogen. One of them is water. Another one's DNA. Those are 3 that are definitely on my list. Hemoglobin might be another one. They know the oxygen carrier in the blood. That'd be another interesting chemical in my... So we got an astatine. We got to vote for neodymium, rhodium, carbon. Bester's liking some neodymium. That's a cool thing, man. The way that can make some really cool magnets. Hey, that's cool. That's a cool idea, Glitch. Crown Bot's liking some astatine. Very rare element. Not much of that's around. Nitric acid's pretty cool, Allie. I agree. It indeed has some interesting uses. I got some experiments where I dissolve some coins, some tokens as well in nitric acid. I agree, Denny. But you know, Denny, there's an even more dense element than tungsten. Does anyone know the most dense element? Oh, come on, Melee. Does anyone know what the most dense element is? Mercury hydroxide. Osmium, Dane is the winner. You got it. Osmium is definitely the most dense element. How about the second most dense? It's really close to osmium. The second most dense element. It's very close to osmium. You got it, Marquette. Iridium. Yep. Iridium is it. Well, hey, folks, it's been fun hanging out with you. It's fun to see some of the beauty of science together. But, you know, we can always be looking at the beauty of science because it's just all over the place, right? I mean, I can go out after this live is over. I go outside, sit on my porch, look at the clouds, and just marvel in the wonder that is, you know, our universe, our world, our Earth. So thanks for hanging out. Always be looking at the, you know, the wonder, the beauty that's around you. I like to say that, you know, the universe is having a party and science gets you on the guest list. All right, folks, we're going to see you next time. Usually do this on the weekend, Sunday, usually, sometimes Saturday. Thanks for hanging out. I'm going to see you next time. So long, folks.